Imagine a world where a particle can exist in two opposing states at once, where computation leaps beyond the binary logic that has defined digital technology for over half a century. Welcome to the realm of quantum superposition, an enigmatic yet promising frontier that is reshaping our understanding of computing. Traditional computers operate using bits, the fundamental units of information, which exist clearly as either 0 or 1. These binary states drive every process from web browsing to complex simulations. But qubits, the cornerstone of quantum computing, transcend this limitation through the principle of superposition. A qubit can exist as 0, 1, or any quantum combination of both simultaneously. This fluid state opens doors to computational possibilities that are exponentially more powerful than anything classical systems can achieve. At the heart of superposition lies the strange beauty of quantum mechanics. Unlike classical systems, where information is rigid and linear, quantum systems thrive in ambiguity and probability. When multiple qubits are entangled and placed in superposition, they create a multidimensional computational space. A system with just 20 qubits can process over 1 million values at once, far outstripping the performance of a classical computer with the same number of bits. But what does this mean in practical terms? Quantum superposition enables machines to perform parallel calculations, solve optimization problems, simulate molecular structures, and crack codes that would take traditional systems millennia to decode. In medicine, it could help identify new drugs by simulating molecular interactions instantly. In logistics, it can optimize supply chains with near-infinite variables. In cryptography, it redefines what is considered secure. Despite the staggering promise, harnessing quantum superposition is no easy feat. Qubits are notoriously fragile, prone to decoherence from even the slightest environmental interference. This fragility demands intricate error correction and stabilization techniques, challenges that are being rigorously addressed by leading tech institutions and quantum pioneers. For tech enthusiasts, understanding quantum superposition is not just about keeping up with the next big thing, it's about envisioning the next era of computation. As this field matures, those who grasp its principles today will be the innovators shaping tomorrow. So here's the question for you. If qubits can be more than just 0 and 1, what revolutionary changes do you believe quantum computing will bring to our world?